Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of calculating correlation coefficient. This is standard A.4A in the great state of Texas, and we are using item number 6 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we've got a table here showing the years and the number of species added to the endangered species list. And what we're looking to see is there a correlation? Okay, so what do we know about correlations? Well, correlations here, they range from, and if you can kind of view it as kind of like a skateboard ramp like this. Okay, so they kind of dip in the middle and they kind of bring back up right here. Okay. So they range from -1 to 1, okay? So if you have a correlation that is trying to relate these two variables, the one variable being the year, right? If we wanted to graph this, it is a linear relationship there. We can put that on a graph. So this 0 is going to be no correlation, right? There's no relationship between the year and the number of species added right here. Anything that's 0.7 and above is going to be a strong negative, or 0.7 and below, actually, if you want to get technical. So that means that as one goes up, the other goes down. It's an inverse relationship. Okay, so anything between 0 and 0.7 is going to be a weak negative. Okay, so that means that as one goes down, the other one kind of goes up. You could do the same thing over here on this side. Anything between 0 and 0.7 is going to be weak positive. So as one goes up, the other one goes up a little bit. And then anything between 0.7 and 1, that's your strong positive. As one goes up, the other one really goes up. So how do we calculate this? Well, we literally do calculate this. But before we do that, we can even eliminate some of these answers, right? So weak negative 0.91, okay? So this doesn't match with this. The weak negative is right here, between 0.7 and 0.9. So we can say that's not going to work. Weak negative 0.09. That's a possibility. Strong negative 0.91. Yep, that's going to fit right here. So that's a possibility. Strong negative 0.09. That fits in that weak area. All right, so we've eliminated A and D just because we remembered the difference between a strong and a negative weak correlation. All right, so how do we actually calculate this? Well, we're going to need to kind of move this over to the side. We actually need our calculator on this one. So first, we want to go to our catalog. You're going to hit second 0, and you're going to make sure that your diagnostic is on. So we're going to scroll down a little bit, go down to the D's, because we are going to use a linear regression model. So let's make sure we've got that diagnostic on. All right, so we're almost there. Got to scroll all the way down. There we go. Hit enter. Diagnostic is on. Okay, we're done. Now we're going to go to our stat and we're going to edit. We're going to enter in our two lists, right? So 2011, 2012, 2013. We're literally just entering in the years here. 2014, 2015, 2016, and then 2017. Now over on this other side, we have to take a little bit more care because these numbers don't necessarily follow any particular order. 74 and then 11. Obviously, you need to get the numbers correct. All right, so let's double check. Our L1 looks good, 2011 to 2017. I've got 19, 15, 89, 66, 31, 74, 11. All right, so now we're going to hit our stat again, but instead of editing, which we've already done, we are going to calculate. Go to that fourth option there, linear regression, AX plus B. Since this does say this is a linear association, right? And if you want to see that right here, it says that linear association right there. So that's our clue. All right, so we're going to enter that. We've already got our list 1, our list 2. And it's that R, it's that negative 0.09. So that negative 0.09 is going to be that weak negative. So our answer here is B.